Okay, I'm going to do out a system of linear equations here, and it's 3 equations at 3 variables. And this is a problem you can find on Skill Builder 3.3, number 1. So the first thing you want to do is make sure that the system is lined up so that you have the x terms, the y terms, the z terms equal the constant terms. And then from there, what we're going to do is collapse this into a 2x2 system by eliminating one of the variables we've got here. Doesn't matter which one you eliminate, you can pick whatever one you want, and just pick one that's easy to work with. So here I looked at it and I thought that it would be easiest to eliminate y, and we could eliminate it first of all by taking equation 1. So let's number our equations here, 1, 2, and 3. Alright, so our plan of attack is going to be eliminate y by first taking equations 1 and 3. And if we multiply one of these equations by a negative, then we'll get opposite coefficients for the y terms, and they're going to cancel out when we add the equations. So that'll be our first step. Equation 1 and 3. And let's multiply equation number 1 just by 1. We'll keep it as is. And equation 3 we'll multiply by negative 1. Then we'll add those two together, and we'll get rid of y. And then we're going to get rid of y again by using 2 equations, and it can't be 1 and 3 this time. We have to do either 1 and 2 or 2 and 3. So let's look again and say, okay, let's just use 2 and 3, and we have to get rid of y again. So I'm going to do equation 2, equation 3, and we're going to leave equation 2 as is and multiply equation 3 by negative 1. So times 1 for 2, and actually we're going to multiply it by negative 2 because we want to have minus 2y here. All right, and you have to always get rid of the same variable in both cases because we're going to be left with a 2x2 system that results from this plan of attack. And we need the 2x2 system to have the same 2 variables. They're going to, in this case, contain x and z. All right, so let's go ahead and do the plan. So first we're going to take equation 1 as is, which is 3x plus y plus 2z equals 3. And then we're going to take equation 3, and we're going to multiply that by negative 1. So everything changes sign. We get negative x minus y minus 5z equals negative 2. Then we go ahead and add those equations, and we get 2x. The y terms are gone. Minus 3z equals 1. And what we're going to do here is we're going to take this and call it equation 4. So I'll just label it, and then we're going to forget about it for a while. Now we're going to go back to our plan of attack, and we're going to use equations 2 and 3 to get another equation, which we'll call equation 5. That also has x and z in it, and 4 and 5 will become our new system of equations, but it will be a 2x2 system, which we will then solve. All right, so equation 2, keep it as is, so just times 1, and equation 3, multiply by negative 2. So let's go ahead and write equation 2. We get 4x plus 2y minus z equals negative 3. And equation 3, we're multiplying by negative 2. So we're getting negative 2x minus 2y minus 10z equals negative 4. And again, we add the equations. And now we're going to have 2x. The y terms cancel out again. Minus 11z equals negative 7. And that is our equation 5. And notice here, we've got a 2x2 system. We're going to solve this system. And it has to have, we've got 2 equations, it has to have the same 2 variables in order for us to be able to solve for one of those variables. Then we're going to back substitute our way to the other variables. So now we're going to take 4 and 5, and you can pretty much forget about the fact that you started with the 3x3 system. Just take your 4 and 5, And pretend you're starting from scratch. We're solving the system 2x minus 3z equals 1 and 2x minus 11z, so this is equation 5, equals negative 7. And it looks like if we do multiply by negative 1 on either one of these, it's going to switch signs, so the x's will cancel. So I'm going to go ahead and leave the top one as is, so just times a 1, and I'm going to multiply equation 5, the bottom one, by negative 1. And that'll give us equation 4, 2x minus 3z equals 1, and the new equation 5, which is negative 2x plus 11z equals 7. And just watch out for signs when you're doing this, because that's the most common place to make a mistake. Again, we're going to add. X terms are gone, and we get 8z equals 8, and now we can solve for z. Z is equal to 1. So we're almost there. We're going to back substitute for x and y. So let's take z, and we're going to back substitute into either equation 4 or 5, and that'll let us find x. And then we can take x and z and go back to the starting equations to find y. All right, doesn't matter which one we use, so I'm going to go into equation 4, which is 2x minus 3z equals 1. So that gives 2x minus 3, and we already found z is 1, so I put in 1 there. That equals 1. 2x minus 3 is 1. So we go ahead and solve for x. Adding 3 on both sides, 2x is 4. Dividing by 2, x is 2. And now we're going to take z is 1, x is 2, and we're going to take both of those into one of our very original equations, so let's look at those again. And it doesn't matter which one you go to. As long as you got x, y, and z in an equation, you can use it. Looks like the easiest one might be number 3. So we're going to go into equation 3. And hopefully I can fit it all here. Let's see, we've got equation 3 is x plus y plus 5z equals 2. We know that x is equal to 2, so let's put that in. Y we don't know, so we leave it plus y. Plus 5 times z is 1 equals 2. So we have 2 plus 5, or 7, plus y equals 2. And solving for y, we get y is equal to negative 5. And we put all 3 of the answers together for an ordered triple x, y, z, which is 2, negative 5, 1. And as a check, you would want to substitute the ordered triple into the equations, into all equations of the system, the starting equations, 1, 2, and 3, and make sure that they do give a true statement in each one. And that verifies that, yes, this is the solution to the system.